2, 1, go.
This week, we interview Chris Domas. In the security news for this week, we're going to talk about WordPress vulnerabilities, go figure, and some Adobe Acrobat vulnerabilities, go figure. All that and more, so stay tuned.
Broadcasting live from G-Unit Studios in Rhode Island, the show where exploits run wild. Packets aren't the only things getting sniffed. Systems aren't the only things getting penetrated. Functions are the only things getting wrapped. And bits aren't the only things getting banged. And these cocktails, they are mighty tasty. It's Paul's Security Weekly.
Black Hills Information Security, the leaders in penetration testing and active defense. Email consulting@blackhillsinfosec.com to request a quote today. NetSparker, the developers of the only false positive-free web application security scanners, enabling you to automatically identify vulnerabilities and security flaws in all of your websites, web applications, and web services. NetSparker scanners are available in 2 editions, NetSparker Desktop and NetSparker Cloud, the enterprise online scanning service. For more information, visit their website at netsparker.com/securityweekly. The SANS Institute, the most trusted source for computer security training, certification, and research. Visit sans.org to explore the full curriculum and latest training offerings.
All right.
Welcome.
And here, right over here, is your host, who forgets that I need to introduce him. He's a man that made me a blueberry martini, and that's not a metaphor. Mr. Paul Asadori.
Welcome, everyone, to Security Weekly. This is episode 447 for January 14th, 2016. Very excited to be here this evening. There are no announcements. How is it possible? Besides Orlando, I feel like we should be talking about.
ICS Summit in Orlando. I think I'm going to be there. No, I'm not going to be teaching, but I'll be there.
Okay.
I'll be, as far as I know, I'll be there. Let's put it this way.
And besides Orlando is later.
Yes. RSA. I'm speaking in the IoT and ICS Innovation Village on Wednesday at 9 a.m.
Is RSA that close?
Yeah. Beginning of March.
Oh, hey, get this. The
Besides Orlando.
Besidsorlando.org.
Yes.
Get that. So you can go there. It's going to be, excuse me, March 12th through the 13th in Orlando, Florida, for the 4th annual Security B-Sides Orlando Conference. And
that typically runs right before SANS Orlando, doesn't it?
I think so.
Excellent.
So they welcome newbies and experts or anyone in between. Making, breaking, protecting, blah, blah, blah. Is what they do.
B-Sides.
Blah, blah, blah. B-Sides Orlando.
B-Sides.
Right.
Good stuff.
I was prepared for that.
Yeah. B-Sides Orlando is good stuff.
On the lines via Skype, we have Mr. Joff Thayer.
G'day, Paul. How are you? Good to see you. Good to be here in this lovely January 2016.
Yes, Mr. Michael Santar-Cangelo is here with us. Welcome, Michael.
I always feel like I have this bar to follow. He's got the stunning good looks, the fantastic diction. I got
Hey, what?
Wait, are you talking about
you
Joff?
don't have anything on me.
I just, you go to him first, and then it's like,
well, because he's first, and when I'm looking from left to right, because...
Yeah, I got it. No, I'm not saying I needed to be first. It's just, hey, I guess, I'm on a beach. I'm still wearing, barefoot.
Sorry, Santa, you had me at diction.
Wow. Mr. Carlos Perez is here with us. Welcome, Carlos.
Hey, good day.
Mr. Jack Daniel joins us on the lines via Skype. Jack, welcome to the show.
Thank you very much.
Yes, we've got a...
Someday Jack might be able to join us back in studio. Same with Carlos.
Yeah.
What I'd
I
rather
don't know
see
if Carlos has ever been in studio.
Jack,
ever.
Joff, and I hanging out down here, and would just all
And
squeeze in.
Santar-Cangelo hasn't been in studio yet, so maybe that's a goal for
I gotta
2016.
make it up there. Yeah.
Yeah, you definitely
Santa
need
and Carlos have to come in the studio. Even better at the same time.
Sometime when it's nice, because
When it's warm.
Carlos doesn't do well in snow.
In the summer. Carlos, we'll bring you up here in the summer. It'll be summer.
Yeah.
It'd be wicked awesome. So it's gonna be an interesting show with all of our a lot of our regular hosts here with us tonight. We do have a very special guest this evening. Chris Domas is an embedded systems engineer and cybersecurity researcher focused on innovative approaches to low-level hardware and software reverse engineering and exploitation. Chris, welcome to the show.
Thanks for having me.
Chris, how did you get your start in information security?
I really just kind of fell into this, I've always liked tinkering with things and breaking things and figuring out how things work, and I think that just inevitably leads you to this field.
Very nice, very nice.
So true.
So
True.
So, Chris, you have a lot of projects that you worked on here. Which one did you want to start with telling our audience about?
Oh gosh, I don't know. Do you guys have a preference?
Let's talk about the
I think they're all fun.
Yeah, the world's first single instruction C
Sure,
compiler.
that's a fun one.
What's the driving force behind this one? Why did you create it? What's the problem you're trying to solve with it?
I can't say I was trying to solve anything. It serves no purpose whatsoever. I thought it'd be a funny thing to try to see if it was possible. So I guess the background is somebody a couple of years ago, a guy named Stephen Dolan, wrote this paper that the move instruction in x86 is Turing complete. So he concludes his paper talking about how awesome it would be for processor architecture if we only had to worry about the move instruction as long as somebody else writes the compiler. So I read that last little bit and thought, well, I've got to try to see if it's possible to actually write this compiler that'll compile anything into only move instructions. So I can't say I was trying to solve a problem or do anything useful. It just seemed interesting.
I'd argue that the problem you tried to solve was to implement the things from the paper. But
Sure. I guess that's
sure.
valid.
So it might be a little bit of a stretch at solving a problem, but sure.
So, but in doing that, does it make programs that use your compiler, do you think, more secure, easier to debug, faster? Like, were there any benefits after you completed the project that you could speak to?
Certainly not faster. Certainly not easier to debug. If anything, it became a whole lot harder to debug. So after I finished it, I was trying to think if there were any practical applications to this thing, and the best I could come up with is it is kind of an anti-reverse engineering tool. It makes it really hard to take the software apart and figure out how it works when it's nothing but the same instruction repeated over and over. So if you want to protect your IP or keep people from exploiting or understanding your code, it could be used for that maybe.
Yeah, but that includes yourself, it sounds like, too, right? If it's hard to reverse engineer, it also sounds like you introduce complexity in actually debugging it.
Yeah, absolutely.
Interesting. So you also developed a memory sinkhole. Tell us about that.
So I showed that at Black Hat this year. So it's an interesting exploit on the x86 architecture. And what makes it a little bit different from most of the exploits people are familiar with is it's an actual hardware exploit. It's a problem built into the architecture itself rather than any software that somebody's written, which means it's really, really hard to patch and hard to get rid of. And it's also really, really widespread. So the idea, the memory sinkhole, was most people are kind of familiar with the rings of privilege in x86, where we've got, ring 3 is kind of userland stuff. It's the least privileged code, and ring 0 is your kernel. It's the most privileged code. So x86 kind of has like more privileged levels than ring 0. So you've got the hypervisor is more privileged than ring 0, and what they call system management mode is more privileged than ring 0. So is the system management mode in particular that I was interested in with this memory sinkhole exploit. So x86 has a lot of different protection mechanisms built up around system management mode to try to help prevent people from gaining access to SMM level of execution. But I found from really just reading some Intel documentations, there's an oversight in the design of these processors that's kind of been there for the last 20 years, where a totally unrelated piece of the architecture called the local advanced programmable interrupt controller, that's the APIC. You can remap where that sits in memory, and by doing that, you can influence SMM code. And if you are really careful with how you do that, you can actually get your own code running inside of system management mode, which is something they've gone through a lot of work to prevent you from doing. So it was a pretty neat exploit.
Now, the attack vector for this, Chris? Would it be like I have to plug a USB thumb drive into it? Do I have to, run firmware on something plugged into the PCI bus? Like, what's my attack vectors to run this code?
Yeah, so really you just need to be able to write to the APIC base register, which means you have to have ring 0 or kernel level access to the system. So a lot of people kind of think, well, the game's over when you've got ring 0 access, but that's really not true. SMM can do a lot of things that ring 0 can't do. So sometimes there are reasons to elevate all the way into SMM. So as long as you have ring 0 access or kernel level access to the system, you can implement this attack.
So what are the advantages if you have ring 0 level privileges to running this code in the SMM?
So a lot of times there's things in sorry, fiddling with my headphones here. So there's pieces of the hardware that are off limits to ring 0 code. So for example, flash chips attached to the processor are often protected from write access, even from the kernel. But SMM can access those kinds of things. It also gives you a convenient place to just really run really stealthy code, because ring 0 can't even see what's going on in SMM. So if you've got some really malicious malware and you don't want antivirus engines to detect that, you can toss it into system management mode where no one else can see it. So there's a couple of different benefits to it depending on what your end goals are. So I kind of demonstrated at Black Hat, just dropping a pretty nasty stealthy rootkit into SMM that traditional malware scanners wouldn't be able to find because it's hidden when it's inside of SMM.
That's interesting. Have you seen attackers adopt the techniques that you talked about at Black Hat last year?
I haven't heard of anybody actually trying to pull this off yet. It's complicated, and there's research from other people in this field that give you much easier ways into system management mode. So there's really not a whole lot of reason to use this when there are so many easier paths to attain the same thing. It's really mostly an interesting attack vector more than a practical one.
Of course, until all those other methods that are easier go away.
Yeah, exactly. It's a fallback until you have to use it.
So has Intel made it harder in future revisions of I'm assuming future revisions of the hardware would have to be coded to be resilient to this attack? Yeah,
I did responsible disclosure with Intel on this issue. They were really great to work with, really, really helpful in doing some of this research. I mean, it turns out that some of their researchers at Intel had actually found this vulnerability a couple years back, and it's been fixed in the newest Intel architectures already. But there's still maybe a 15-year window of processors that are vulnerable to this. But if you've got anything made in the last couple years, you're safe.
Interesting. That's like 2% of the systems we have here. Very cool. Chris, your other project is called, well, first I want to stop and see if the other hosts have questions for Chris on his compiler or the SMM attack you talked about.
I do not.
Throw it out to Ja, Mike, Carlos, Jack. Alrighty.
Well, wait, I do have one.
I thought someone would. Go ahead, John.
Chris, why'd you do it? Maybe Paul already asked that. I don't know.
No,
I didn't know.
That's a question I ask myself a lot. I don't know. Sometimes I like to find. I pursue any idea that just seems interesting. I don't necessarily ask, is it useful or is this practical or does this accomplish anything? And sometimes when you stop asking whether or not something's useful, it just becomes a lot more fun. You stop worrying about those details and get to work on the technical side of things. So mostly, I guess I did it because I thought it was fun, not because it served any specific purpose.
You know, I can completely relate to that. I have the same feelings a lot of the time with a lot of the activities I'm involved with, and I think about the practical applications later. So that's a great answer.
Well, there's been a lot of technology over the years, right, that even if they had an original intention, it didn't work out, they find another usage for it, or it was just research, and then someone figured out, oh, well, we can really use this now because of X, Y, and Z or whatever. So that's
Yeah,
pretty cool.
Someone else can answer the questions of what this is good for. I'm just having fun making it.
Nice. So your other project, Chris, is called Recyc. Did I say that right?
Yeah.
So what's that
So
about?
short for reverse engineering psychology. So that was another. It's probably the most pointless of all the projects I've worked on. So the idea behind this, I don't know if you guys are familiar with, or if your listeners will be familiar with the idea of control flow graphs in programs. So the idea is if you've got like an if-else statement in the program, you can kind of think of that as some code that's going to execute, and then it branches to one of two locations. That's your if-else, and then once either of those locations are finished executing, it converges again. So you can sort of lay out your code as this series of little nodes that are going to execute, and you connect the nodes based on the order that they're going to execute in, the path that execution is going to take. So that's the control flow graph of the program is just this graph of nodes. So I do a lot of reverse engineering work, and a lot of what we look at when we're reverse engineering software, when we're taking software apart, trying to figure out how it works, is we look at the control flow of a program. So looking at these CFGs, these control flow graphs, I can see, well, this part's an if statement, and this is a for loop, and this is a switch statement. And by looking at the layout of these nodes, you can kind of quickly begin to understand what this program's trying to do. And from that, you can either exploit it or do whatever your end goals are with reverse engineering. So most reverse engineers use this software called IDA Pro for looking at the control flow for programs. And I've always wondered when I was looking at these control flow graphs, whether or not if you really carefully crafted the logic in your program, if you could lay out the control flow so that it drew an image. So if you really carefully wrote out your if statements and your for loops and everything else, could you have these interconnected nodes of your program form some kind of picture when you look at the control flow for the program? So no purpose to that whatsoever, just a question I've always had when I was working with these things in IDA Pro. And it turns out you can. So kind of the idea I came up with after I made this little framework for writing programs so that the control flow made images, I thought to myself, as a reverse engineer, I look at these control flow graphs constantly, and it would be, I don't know, it would kind of wear on your psyche if I was looking at something really horrific in the control flow graph, if I was looking at a demotivational message in the control flow graph. So I thought if I wanted to make somebody not reverse engineer my code, maybe I could break down the reverse engineer like by sending them horrible messages in the control flow of my program. So I sort of looked at this as a possible anti-reverse engineering tool. Just by laying out the control flow for your program very carefully, you could communicate with whoever was looking at your code somewhere in the future, and maybe make them give up on reverse engineering your code if you told them the right things.
So you're saying if I'm in IDA Pro and I'm reverse engineering, I'm looking at a control flow graph, and it's goatsy, that was you that coded it, right?
Yeah, exactly. So if I had to look at goatsy for 30 seconds, I'm gonna go up. I'm gonna give up. I'm not gonna try to reverse engineer that program. So, most people, when they look at anti-reverse engineering techniques, we're talking about anti-debugging and code obfuscation and things like that. But I sort of looked at this as a different, maybe more sinister approach to anti-reverse engineering.
That's interesting. Now, it's funny, Chris, you say that that's the probably the least useful of all of them, but yet I think it is the most fascinating.
Yeah, it was. I mean, that's exactly it. If I had stopped at the beginning and thought, what purpose does this serve? Maybe I wouldn't have done it. But it definitely was one of the most fascinating ones to actually work on, to see how you needed to lay out your program in order to generate this kind of stuff.
Nice. I can see it now that the French taunter from Monty Python and the Holy Grail is there taunting you a second time while you're trying to debug this code.
Absolutely.
And my mind immediately went to control flow porn. I don't know why, but
see, then Geoff, you'd want to continue to
right. Well, that would sort of flip it
right.
180
That's the
degrees,
opposite.
where you would be laying down an incentive to continue to reverse engineer code. It's like, ooh, cool image. Let me keep going. Anyway.
I suppose it depends on the type of porn. I mean, clown porn might scare some people away.
I know it would scare.
It would scare John. Yeah.
It would scare John Strand. That's exactly what I was going to say, Paul.
Very much so. Chris, you've got along the lines of reverse engineering and visualization. You created a software visualization tool called Canter Dust. Why don't you tell us about that?
Yeah, so Canter Dust was something I came up with a few years ago. So that was another just sort of following some random ideas to see what came out of it. So a guy named Greg Conti gave a really interesting presentation at Black Hat a couple years back. He had this really simple idea that I found just absolutely fascinating. So his idea was like if you're looking at binary information and you have no idea what you're looking at, like none of your tools tell you what this is, you've never seen it before, he came up with a way to like translate binary information into some sort of visual abstraction. And he showed how you could like look at a picture of this binary information instead of the actual binary data. And by looking at the picture, you could tell what this information actually was. And there's some similar research from a guy named Aldo Cortese, and I think Dan Kaminsky had also published a paper on some of these ideas. So I kind of used all of their research as a starting point for this tool that I ended up calling Canter Dust, which gave a way of trying to examine and explore arbitrary data when you don't know what you're looking at beforehand. So like a lot of the tools we use to look at data kind of assume that somebody's told the tool at some point, well, this is how a PE executable is laid out, and this is how a PDF is formatted, et cetera, et cetera. But if you're looking at data that doesn't follow any of those known patterns, if it's not like anything you've ever seen before, it can be really hard to dissect and understand what it is. So Canter Dust was kind of a way of taking some arbitrary files and looking at it from a visual abstraction perspective and looking at visual patterns inside of the data with the goal of trying to understand what that data really was from those visual patterns.
Yeah, it's interesting. The first one was actually introduced to data visualization was in Josh Wright's class.
Yeah.
The first time I ever actually did it, right?
Yeah.
Because you take a bunch of wireless packets and you do the visualization on them, and if they're encrypted, they look a certain way. If they're not encrypted, they look a different way.
Right.
So
Yep.
that's pretty much the premise, I think, of what you're talking about.
Yeah, absolutely. In just a couple of seconds, you can really, really quickly figure out exactly what you're looking at when you take a different perspective like that. So it can be a really useful application.
Right, and that was one of the things that Josh found too. That being able to visualize that was really awesome. In that he was doing some analysis on something proprietary, and he looked at it, and sure enough, the character distribution was there, but it was off by 13 characters. It was shifted 13 characters to the right. So, by doing something like that, that's awesome.
Yeah.
And Chris, this very much reminds me of sort of doing wireless analysis for unknown sort of wireless signals of all sorts of varieties. By using like a waterfall display or histograms and some of those types of things. Taking an actual look at this unknown data that you've never seen before, and you can start to draw corollaries by building quote that mental institutional knowledge of things that you've seen before. And I think that's absolutely fascinating.
Yeah, absolutely. It's really that exact idea of trying to make sense of something that you haven't seen before very quickly, and certainly that kind of wireless data or signals analysis. It's got a lot of kind of neat applications there.
Yep, and definitely a different approach to looking at potentially the same problem over and over again, because definitely people learn and process information significantly differently, and some of us are visual learners and some of us are not. So fascinating.
Yeah, absolutely. It's not a silver bullet. It's not going to solve all the problems, but it can be very valuable just to look at things from a different perspective. So I think that's very much what it gives you.
Yep, very cool.
Cool. Any other questions that we have for Chris? Chris, do you have any projects you're working on now?
I do. I have a lot of things kind of in the pipeline. I don't really want to give any of those away just yet. I think 99% of the things I start end up being spectacular failures. So I try not to talk about anything until it's actually finished and successful. So I do have stuff in the works, but we'll see where it goes.
Excellent.
Chris,
Excellent.
What advice do you have for those listening that are like, well, I really want to do reverse engineering. Like, where do I start?
It's a tough question. Really just take your favorite executable, if it's calc.exe or whatever, and just start looking at the assembly code inside of that. Start debugging it, and if you look at it for long enough, I promise it'll start making sense eventually.
And I think a lot of people are kind of put off, like they need a deep knowledge of a assembly language or a deep engineering background. But I think really you need a lot of patience, and you can use a lot of the off-the-shelf tools to do a lot of reverse engineering.
Yeah, absolutely. I think a lot of people look at assembly or something like that and think, this is really complicated stuff, and I don't have the background for it. But that's not at all true. As long as you're patient and can look at what's going on and persistent, you'll figure it out. So it's definitely something anybody can pick up.
Excellent, Chris. When we introduced you, it was definitely noted that you were a quoted embedded systems engineer. How are the reverse engineering and any of the software development type of stuff that you've been working on played a role in doing any embedded system stuff?
So I guess I'm called that because I do a lot of low level stuff. But let's see. I think knowing the reverse engineering side of things, knowing that low level side of things, how to break things, how to take stuff apart, looking at how other people have built things, certainly gives you a good foundation for building things up, as well as maybe how I would answer that question.
Okay. I like it. I like it.
Okay.
And I can definitely see those corollaries that going from reverse engineering and/or to the hardware side and embedded system stuff. It's a system of building, and it's a system of tearing all those buildings down and figuring out how they were constructed.
Right. Sort of. I mean, it's different fields, but it's always the same mentality. So.
Excellent.
Those hosts on via Skype, any more questions for Chris?
I got nothing. Sorry.
Well, Chris, that means it's time for 5 questions with Security Weekly. Are you ready to play 5 questions?
Yeah, let's do it.
Okay, 3 words to describe yourself.
Geez, putting me on the spot. Smart, handsome, and persistent.
If you were a serial killer, what would be your weapon of choice?
Axe.
If you wrote a book about yourself, what would the title be?
Christopher Domus, A Life of.
In the popular game of Ask Grabby Grabby, do you prefer to go first or second?
There's no winning there. I'll go second there.
Or there's a whole lot of winning,
or
depending.
There's a whole lot of winning, right.
Sure, it depends on your perspective.
Yes.
Choose 2 celebrities to be your parents.
Let's see. Let's say Alan Rickman and Sandra Bullock.
There you go.
Interesting.
Nice.
Right.
I like Sandra. That's
a good one.
And Alan Rickman, given his recent departure.
Yeah.
That's true. Yeah. Nod to Alan. So excellent.
Well, Chris, thank you very much for appearing on Security Weekly.
Thank you, guys.
And Chris, is there a blog or Twitter account or something you want people to follow to keep up with your work?
Yeah, sure. So if you're interested in getting updates on any of the things I've talked about or any of the future projects I work on, my Twitter handle is XOR, EAX, which is good luck with that one. But
no move command? What? Come on.
That's pretty funny. Excellent.
But that one is in the show notes. Yes?
Yeah, we'll put a link in the show notes to that.
Yeah.
Awesome.
Excellent.
Chris, thank you so much.
All right, thanks, guys.
And with that, we're going to take a short break, come back, and talk about the stories for this week. So stay tuned. Don't go anywhere.